Hello and welcome to this video about mixture problems. The goal of this is to kind of introduce the concept to you and also to really provide a good visual for what's happening here with mixture problems. So let's start off with a good example of what you might see as a mixture problem. Let's say you have 5 liters of a pure solution. How much of a 50% solution is needed to make a 75% solution? Now, take a second, look at it, read it, process it. I bet if you tried hard enough, you could probably figure out what the answer is, especially with these numbers. But I chose these numbers because they're easy enough to demonstrate and they'll help show us the process that we need to do this. And when I was thinking, how can I show you how to do this, I figured I'd mix things up a little bit. And so I want to use colors. I think colors will help us out a lot. So let's change this with that. And let's say you have 5 liters of a pure green solution. How much of a 50% green solution is needed to make a 75% green solution? Now you might be kind of wondering, right, well, what exactly are we supposed to do with that information? Well, let's start breaking some of it down. What does it mean for something to be pure? Well, pure means that we have 100% of something. Or if we were to think of that as a fraction, 1 over 1. What we are going to do is we're going to add a bunch of 50%, 50%, which is 1 over 2, to ultimately get something that is 75%, which is equal to 3 over 4. And when we're talking about 75% green and 50% green, we're talking about one green part compared to all the parts. And our goal is to get 3 green parts to every 4 parts there are. And so let's think about it like this. Let's just say this is what a 100% green solution looks like, right? You have a bunch of green pieces. 50% green would look something like this. So this is 50% green. And what we're going to do is this kind of helps us with the visualization because, believe it or not, this brings back a concept from last year, maybe the year before, of a unit rate. If we were to take a look at 1 unit of this green solution, it's got to be 50-50, or for this 50% solution. And that means it has at least 2 components. So when we cook up our 5 liters of pure green, we're going to let 1 liter be represented with 2 pieces. So this represents 1 liter. And if we want 5 of them, we got to put 5 of these together. So, let's see, is that 5? That's 5. So now we have here our 100% of 5 liters. And so remember, 1 liter is that right there. And so what we're going to do is start adding a bunch of these, and we got to figure out how many so that we end up getting a ratio that looks like 3/4. And so as it stands right now, like this ratio right here of green is 10 over 10. There are 10 greens, there are 10 pieces. Here we have 1 green, 1 white, and so we have a grand total of 12 pieces. Now we add to the 10, 11 of them are green. 11/12 doesn't look like 3/4, so that's not good enough. What we're going to do, add another one. Now how many pieces do we have? We still have 10 plus the 4, so this becomes 14. And how many greens? Well, we've added 1 more green, so we have 12. That could be reduced. That's 6 over 7, not quite 3/4. So, got to repeat this process again. Let's add a third one. And when we do that, we're changing our numerator and denominator yet again. So we have 16 pieces overall, and we have 13 of them as green. That doesn't reduce, it's not 3/4, so gotta add another one. Now we're looking at 18 pieces, and 14 of them are green. We're getting close now, because if we reduce this, this is 7 over 9. And for those of you who know your decimals, that's 0.7 repeating. So we're super duper close. Let's take one more. When we take one more, we end up getting 20 pieces total, and of those 20 pieces, 15 of them are green. And this gets reduced to 3/4. And so now we've done it. And this is what I'm thinking. That's why I said I think you guys probably figured this out if you just thought about it long enough. This is 100%. This is 50%. We're trying to split the difference between the two of them. They're going to have to be the same. So the answer to this question here is 5 liters of 50%. Okay? Now, this is a great visual for how this works. Let's think about this algebraically, what we've just done. And so let me clean up some stuff. Let me move this here, move this there. Let's do some erasing. All right, so we ended up saying what the answer was 5 liters of 50%. So let's keep that over there. Now we said that this was 5 liters, and it was 100%. We have to add all of this, which at the time we didn't know how much there was of it, but we did know that it was 50%. And so the way we're going to set up the structure for these is we have to add an amount, or so we have to add up several things. So we're going to put some placeholders here. We have the quantity times the percentage. So pure, meaning 100%, is just 1. An unknown, which we didn't know how many it was going to be, but we did know it was going to be 50%, which is 0.5, equals, and then here's where the structure gets into play a little more. Overall, we have the answer. We know this. So we know that it was 75%, which is 0.75, but the tricky part is how much is there? Well, here we have 5 liters. We didn't know how much there would be, but we're adding them together. So it's going to be in parentheses 5 plus x. And here's the deal. If you were to solve that, you're going to get x to equal 5. And so this is just a great little introduction for how this works and visually what's going on here. So hopefully this is starting to make some sense. And as we continue to practice it, you'll get a little bit better with how to set these up.